All right, so we're going to talk about complex numbers, and I recognize it may have been a while since you've looked at complex numbers, so let's remember that when we're talking about complex numbers, we're talking about numbers that have a real part and an imaginary part. And really, all real numbers are complex numbers with a zero imaginary part. Now, the imaginary part includes this symbol I, which is simply the square root of -1. So, at some point in here, mathematicians and engineers realized that they needed a square root of negative numbers. And so, in a fairly classic mathematical trick, what they said was, well, okay, so let's just imagine that there is a number that is the square root of -1, and we'll call that I. And it turns out that this number really does have to exist in order to explain a lot of what is seen in electronics and physics. So there is a square root of -1, and it is I. Now what that means is that lets us handle things like the square root of -9. Because we rewrite that as a square root of -1 times the square root of 9, square root of -1. Well, let's write this in a different way. Let's write this as a square root of 9 times the square root of -1. Square root of 9 is 3. Square root of -1 is I. So the square root of -9 is 3i. All right, so that is an imaginary number. Now a complex number, typically, we write these as z is just a complex number, and that equals a plus bi. A is the real part, bi is the imaginary part. All right. So, up until now, what you've always been told is that we can't plot imaginary numbers. What I want you to do is think about, we're going to plot on the complex plane. So we're going to consider plotting on the complex plane. So what we're going to do is make a grid. And what we're going to do is we're going to put the real part on the horizontal axis and the coefficient of the imaginary part on the vertical axis. So suppose I wanted to plot the number, the complex number, 3 minus 4i. Well, I would go out 3 and down 1, 2, 3, 4. So I have now plotted the number 3 minus 4i on the complex plane. Okay, we haven't done that before, but we can do that. Okay, now remember that when we add complex numbers, we simply add real to real and imaginary to imaginary. So we'll come back to this plotting in a minute. Let's remind ourselves about adding real numbers. So 3 minus 4i plus 2 plus 5i, that is 3 plus 2 plus -4 plus 5i, or 5 plus I. So remember that the real part combines with real parts and imaginary parts combine with imaginary parts. So let's suppose we want to multiply 2 minus 3i times 1 plus 4i. This is really the multiplication of two binomials, so we have to FOIL this out. So this is first times first plus outer times outer plus inner times inner plus last times last. So first, outer, inner, last. Which means that this is actually 2 plus 8i minus 3i. Now here comes the tricky part. Negative 3 times negative 4 is negative 12i squared. I squared is negative 1, so this is actually negative 12 times negative 1. So what I have here is 2 plus 5i minus 12 times negative 1, which is negative 12 times negative 1 is plus 12. 12 plus 2 is 14 plus 5i. Having gone through all of that just to multiply, let's look at how we will divide. So if we want to divide this, and you will remember, I hope, doing this at some point. So if we want to divide complex numbers in the rectangular form, which is what we're in right now, we need to multiply by what we're doing is we're going to rationalize the denominator. So we're going to multiply by the complex conjugate of the denominator. So we're going to multiply both top and bottom by 4 plus I. And now we FOIL. So on top we end up with 8 plus 20i plus 2i minus 5. And on the bottom we end up with 16 plus 4i minus 4i minus 1 plus 1. So minus I squared is minus negative 1, which means plus 1. So what we end up with is 3 plus 22i over 17, or we usually write that as 3/17 plus 22/17 I, and reduce those fractions if we can. All right, now think what it would look like to apply, say, the fourth root, say, or fourth power. So say, well, do either. Suppose I wanted to take 3 minus I to the fourth power, or 2 times minus 3i to the fourth power. Yeah, that'd be painful, right? Because I'd have to do 2 minus 3i squared times 2 minus 3i squared. Have to expand out both of those. You can see it's going to get ugly because I'm going to end up with 2 squared is 4 minus 12i plus 9i squared means minus 9 times itself. Combine those and then FOIL again. So end up with negative 5 minus 12i squared. Yeah, yeah. You can see this is getting ugly, yeah? So you end up with negative 5 squared is 25 plus 6,120i minus 144. Yeah, and combine negative 144 and 25. That's just to go to the fourth power. Imagine trying, you can't even think about how to take a fourth root, and imagine trying to apply a higher order exponent. This is where life gets simplified, believe it or not, by the polar form of complex numbers, and we're going to talk about that next.